So you type a question into ChatGPT, and boom, you get a perfect answer. It can tell a joke, write a poem, even code. I mean, how does it do that? It really feels like magic, right? Well, it's not. It's actually a super fascinating story of how we got here, and we're going to pull back the curtain and see exactly how this whole thing works. All right, let's start with the big question. How does a computer actually understand what you type? I mean, think about it. You type, "What's the capital of France?" To the computer, that's just a bunch of pixels, a string of characters. It has no idea what capital means or what France is. So how on earth does it get from that jumble of letters to the answer Paris? That's the puzzle we're going to piece together. Okay, so to really get how we ended up with something like ChatGPT, we've got to go back in time. The first attempt at AI, well, it was about as simple as you can imagine. The idea was, hey, let's just write down a rule for literally everything, a giant, massive rule book for the computer to follow. Yeah, this old school way was called expert systems, and it was all based on simple if-then rules. You know, like if an email has the words free money, then it's probably spam. Or if a patient's temperature is over 100, then they've got a fever. For stuff like chess, it was like, if my knight can move here and an enemy pawn is there, then capture it. It sounds super logical, right? But yeah, there's a pretty huge problem with this. The problem is that the real world is, well, it's messy. How do you write a rule for sarcasm? Seriously, think about it. If you say, oh, great, how is a computer supposed to know if you're actually happy or if you're totally annoyed? Or what about weird phrases like, it's raining cats and dogs? A rule-based machine would just get completely lost. It turns out you can't write a rulebook big enough for language. The whole system is just way too brittle. So, that old way was a dead end, and this led to a complete revolution in how people thought about AI, a total game changer. The new idea was, what if we stop trying to teach the computer rules? What if instead we just show it a ton of examples and let it figure out the patterns on its own? And right there, that was the birth of machine learning. The best way to think about this is how a little kid learns, right? You don't hand a toddler a textbook on what a cat is. You just point to cats and say cat over and over. They might see a small dog and guess cat, and you'll say, nope, that's a dog, and their brain just kind of adjusts. Machine learning is exactly that, but on a totally insane scale. We show it millions of cat pictures, it makes a guess, we tell it yep or nope, and it makes a tiny adjustment. Do that a billion times, and it gets scarily good at knowing what a cat is. Okay, awesome. So we can teach computers with examples, but there's another huge hurdle we have to get over. You see, computers don't get words. The word king or apple means nothing to them. They only speak one language, numbers. So the big question became, how do we take the meaning of a word and turn it into numbers that a computer can actually crunch? And the solution to this is a brilliant idea called word embeddings. And I'm not kidding, this is basically the secret sauce to all modern AI. The idea is to take every single word, and instead of giving it one number, you give it a whole list of numbers. Think of it like a location coordinate on a map, or a recipe with lots of ingredients. This list of numbers is called a vector, and it's basically the word's DNA, capturing its meaning in pure math. So how does that actually work? Well, each number in that long list represents the word's score on some abstract quality or dimension. For example, the words king and queen would both get a super high score for the dimension of royalty, right? But they'd have different scores for gender. And a word like apple, it would score high on is it edible and basically 0 on royalty. Suddenly, we've turned abstract concepts into cold, hard numbers. And what you end up with is pretty amazing. All those number lists act like GPS coordinates, placing every word on this giant, invisible map of meaning. So words with similar meanings, like apple and orange, end up really close to each other, and words that are totally different, like apple and democracy, are super far apart. We literally turned language into geometry. How cool is that? Okay, so we've cracked the code on turning words into numbers. That's a huge deal. But wait, there's another problem. A sentence isn't just a random jumble of words, right? The order matters. The next big challenge was getting the AI to remember the context, to remember what was said at the beginning of a sentence. And let me tell you, the early models were awful at this. I mean, they basically had the memory of a goldfish. So the next logical step was to design a model that tried to act more like us. You know, to read a sentence one word at a time from left to right. The idea was for it to build up a sort of running memory of what it just read. These models were called recurrent neural networks, or RNNs for short. But this way of reading had a massive flaw. Just look at this crazy long sentence. The cat, which was sitting on the mat that I bought, yada yada yada, was happy. By the time the poor model gets to the word happy at the very end, it needs to know that happy is describing the cat from the very beginning. But after all that stuff in the middle, its memory just faded away. It completely forgot what the sentence was about. This was a huge roadblock, and it's called the long-range dependency problem. And for years, this forgetting problem just stumped everybody. It was a major bottleneck in AI. And then, in 2017, this paper comes out with a super simple title, Attention is All You Need. And this paper, oh my gosh, it introduced an idea so powerful, so brilliant, that it unlocked everything that makes models like ChatGPT possible today. Here's the big revolutionary idea. Why are we forcing the AI to read like a human, one word at a time? What if we just gave it a superpower? What if it could look at all the words in a sentence at the exact same time? So instead of going step by step, it just sees the whole picture at once. And that superpower is called the attention mechanism. And it's genius. Here's what it does. When the model is looking at a single word, let's say the word it, the attention mechanism lets it scan the entire sentence and figure out which other words are most important for understanding what it refers to. It basically draws connection lines between related words, no matter how far apart they are. Okay, let's make this super clear with an example. Check this out. We've got two sentences that are almost the same. The animal didn't cross the street because it was too tired. And the animal didn't cross the street because it was too wide. See? And that first sentence, when the model sees the word it, the attention mechanism sees the word tired and thinks, okay, tired, that describes a living thing, so it pays attention back to animal. But in the second sentence, it sees wide and thinks wide, that describes a place, so it pays attention to street. It's figuring out the context on the fly. And just like that, the forgetting problem is solved. And that brings us all the way to today. That attention mechanism is the beating heart, the core engine, inside the technology that powers ChatGPT. That technology is called a transformer. So now that we have all the puzzle pieces, we can finally put them together and show you the simple recipe for how ChatGPT actually works. And you know what's wild? The recipe is actually shockingly simple. Just 3 ingredients. First, you need the engine. That's the transformer architecture, built on that awesome attention idea. Second, you need the knowledge. You just feed it, well, a huge chunk of the internet, trillions of words. And third, you give it one and only one simple job. Predict the very next word. Seriously, that's it. See, ChatGPT isn't thinking about entire sentences or paragraphs. It's only thinking about one single word. The next one. When you give it a prompt like the quick brown fox, it just predicts the most probable next word, which is probably jumps. Then it takes that whole new phrase, the quick brown fox jumps, and feeds it right back into itself to predict the next word. And it just keeps doing that, over and over. All that amazing, complex text you see, it's all built one word at a time. And this has completely changed the game for AI. In the old days, if you wanted an AI to translate, you had to build a translation AI. If you wanted one to summarize text, you had to build a separate summarization AI. Each task needed a specialist. But now we build one gigantic foundational model, train it on pretty much everything, and that one model can be nudged to do almost anything you can think of with language. Translation, coding, writing poems, you name it. All right, let's do a super quick recap of the journey we just took. We started with those clunky if-then rules that just couldn't deal with real life. Then machine learning came along and let computers learn from examples. The big breakthrough came with word embeddings, which turned words into math. We tried making models that read word by word, but they had terrible memories. And then the game changer, the attention mechanism, gave AI the superpower to see everything at once. And that's what ChatGPT uses to do its one simple trick. Just predict the next word over and over. So there you have it. You now understand the fundamental ideas behind what is arguably the most transformative technology of our lifetime. It's not some unknowable magic, right? It's just a series of incredibly clever ideas, each one built on the last. And so the real question isn't how does it work anymore? The real question is, now that we have this, what are we going to do with it? What big problems are we going to solve next?